We now discuss the solution of a problem from the section Vector Algebra. The problem is related to the concepts of dot and cross products of vectors. This question has appeared in the Joint Entrance Examination Main held on 6th April 2023 in the first shift. The given question is, let the vector A is equal to 2i plus 3j plus 4k. Vector B is equal to I minus 2j minus 2k. And vector C is equal to minus I plus 4j plus 3k. If the vector D is perpendicular to both the vectors B and vector C, and the vector A dot the vector D is equal to 18, then mod of the vector A cross vector D square is equal to, we are given four options. We are given three vectors, vector A, vector B, vector C. It is given that D is a vector perpendicular to both B and C. Further, A dot D is equal to 18. Required to find mod of A cross D square is equal to. We now discuss the solution of the problem in detail. We are given the vector D is perpendicular to both the vectors B and C. B is here, C is here. That means D, the direction of this vector D is along the vector B cross C. The direction of D is along the direction of the vector B cross C. That means the vector D is equal to lambda times B cross C for some scalar lambda. Now that is equal to lambda into, for B cross C we have written the determinant ijk, and the second row is the components of B, the third row are the components of C. And expanding by means of the first row we get this. Simplifying we'll get lambda times 2i minus j plus 2k. To determine this scalar lambda we are given A dot D is equal to 18. So in that A, the vector A, 2i plus 3j plus 4k dot D, lambda times 2i minus j plus 2k is equal to 18. This will imply lambda times, take the dot product, 2 into 2 plus 3 into minus 1 plus 4 into 2 is equal to 18. Simplifying, we will get 9 lambda is equal to 18. That will give you lambda is equal to 2. Thus we get the vector D. So the vector D is equal to lambda times that vector, that is 2 times of 2i minus j plus 2k, multiply, we will get 4i minus 2j plus 4k. We got D and we know A. Find A cross D. Then take the modulus square, that will be your answer. Right. So we have the vector D, 4i minus 2j plus 4k, which we have seen in the last slide. Now required to find mod of A cross D square. So we first find A cross D, that is equal to the determinant, first row ijk, second row the components of A, 2, 3, 4. Third row the components of D, that is 4 minus 2 plus 4. Expanding this determinant by its first row and simplifying, we'll get 20i plus 8j minus 16k. Now take this A cross D, mod square, find out mod of A cross D square is equal to 20 square plus 8 square plus minus 16 square. That will be equal to 400 plus 64 plus 256. When added, you will get 720. So the answer for mod of A cross D square is 720, and this appears against option 4. So option 4 is here. So the answer to this question is option 4, and that is the detailed discussion of the solution of the problem related to the concepts of dot and cross products of vectors from vector algebra. And it is definitely very easy question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.